And I had a student ask about 8.4 homework, number 2. So a vaccine to prevent a severe virus was given to children within the first year of their life as part of a study. The study reported that 3,033 children randomly assigned the vaccine. 63 got the virus. Of the 1,541 children randomly assigned the placebo, 37 got the virus. So we're going to try to compare those two. First, I need to find the sample percentage of children who caught the virus in each group. So who caught the virus in the vaccine group was 63 out of 3,030. I'm sorry, 3,033. And I get 2.1%. Round to 2 decimal places. 2.07%. Oops. 63 divided by 3,033. Oh, 2.08. Ah. I just rounded on. Find the sample percentage who taught in the placebo group, so that would be 37 out of 1,541. So that is 2.40%. Oh, and we know 2.40 is greater than 2.08, but we want to know if those differ statistically from each other. So the sample percentage certainly is lower in the vaccine group. And we're going to test it. So we're testing whether the percentage in the vaccine group is lower. So I'm going to go to StatCrunch. Again, this is a proportion. It's a question about a proportion, but this time I have 2 samples with the summary. And so I had 63 out of 3,033, and then I had 37 out of 1,541. Let me go check those numbers, make sure they're right. Yes. My hypothesis test then is whether this one, sample 1, turned out to be a smaller percentage. So I want less than 0. When I subtract these two percentages, 2.08 minus 2.40, I expect to get something less than 0 if this one's actually smaller. And I get a z statistic of negative 0.71. That's about how far I am from the mean. And then I get a p-value of 0.2395. That's a pretty big p-value. Oops. Oh, round to 3 decimal places. How many of you do that? Frustrating. Continue. Now I have to make a decision. My p-value is 0.24. I'm comparing that to 0.05. In this case, my p-value is not lower than my level of significance, so I will not reject the null hypothesis. So I have do not reject, do not reject. There is not sufficient evidence to conclude the vaccine is effective in reducing. Or there is sufficient evidence to conclude it's reducing. Well, if I reject the null, if I do not reject the null, I'm not rejecting that the two are equal. Therefore, there's not enough evidence to say that one reduces. Oops. And that's how I would do a 2-sample proportion hypothesis test.